Welcome to this EXTOL recorded product demonstration. This is Jim O'Leary, and with me today is Dave Ogazalik. Together, Dave and I will show how you can reduce the time you spend creating data transformation maps by 70% or more with Smart Mapping, a signature feature of our new EXTOL Business Integrator version 2.5 release. EXTOL Business Integrator, or EBI, is a platform-independent solution for creating and maintaining non-invasive business-to-business, application-to-application, and data integration processes. You can use EBI to transform and integrate any combination of XML, EDI, database, flat file, and spreadsheet document types. But what really makes EBI special is how quickly you can create and deliver those processes. And one of the major reasons for that is Smart Mapping. We'll get to Smart Mapping in just a minute, but first, let's look at the importance of data transformation to B2B integration in particular, and why improving the efficiency of the mapping process is the single most effective way to save time in integration projects. Unless your company can dictate the terms of B2B integration with your trading partners, there's a good chance that you spend more time and money creating maps for data transformation than on any other integration task. This diagram shows in relative terms the amount of time spent on various design time activities on the left, like mapping, document definition, process modeling, and endpoint interface configuration, compared to time expenditures on runtime activities on the right. As the sizes of the two main boxes imply, much more time is spent on average creating, deploying, and maintaining integration processes than is spent managing their operation. And when you break down the design time activities on the left and look at where most of that time is spent, EXTOL has found that on average, companies with many customer relationships, like manufacturers and other providers of consumer packaged goods, and intermediaries in transportation, distribution, logistics, healthcare, and other sectors, spend around 60% of integration project time on data transformation mapping. Most of us think of mapping as a simple drag-and-drop exercise, defining data movement from a source document to a target document. But there's a lot more to mapping than data movement. It also includes data validation, data enrichment, data transformation, data routing, and even some process automation functions. Specifying and maintaining all of the functions listed on this slide as part of the mapping process can be a complex, time-consuming, and error-prone endeavor, and pushes the limits of conventional mapping tools. The right mapping architecture and user interface choices can not only make the integration of these functions more intuitive and less complex, but also can set the stage for automating some of the most tedious and error-inducing aspects of mapping, as we'll see in a minute. But first, let's look at a comparison between the most common mapping approach and the one EXTOL uses to see why the differences are so important to mapping productivity. The figure on the left depicts a conventional drag-and-drop mapping interface. The crisscrossing lines represent mapping associations between elements in the source document on the left side and elements in the target document on the right side. To specify the data transformations needed to produce each output value, the mapping tool user must configure or specify functions in the middle represented by the small icons. While conventional mapping tools make drag-and-drop association easy, they suffer from a number of critical disadvantages. For example, maps become unintelligible as the volume of crisscrossing lines increases, making large document transformations very difficult to create and maintain. Second, the details of the transformation functions in the middle are hidden unless a function is selected, and that makes it difficult to understand and validate what the map is doing. Third, transformation functions that are dependent on document structure are hard to locate and identify, and that makes it difficult to understand map organization and flow. And finally, because the visual representation is not a complete specification of the map's behavior, a second representation must be used for project documentation, making validation and maintenance more difficult. EXTOL's approach to mapping, as shown on the right, is different. Unlike other drag-and-drop mappers, EXTOL uses a structured rule generation foundation that is easier to understand and modify, particularly when mapping very large documents. So let's move to our demonstration and see how that works. Dave?
Thanks, Jim. EBI's mapping interface consists of two rule types. The first, a composite rule, is used for controlling records and segments and to also group like rules together. The second, called basic rules, are used for leaf-level actions such as move, concatenate, and substring, to name a few. Mapping is as easy as dragging from the source document to the target. You can also create more powerful rules by dragging and dropping inputs and outputs into actions. You can use built-in actions to do things like performing calculations and manipulating strings, or create your own actions that perform lookups, invoke custom formulas, run OS commands, or call external applications, web services, or business processes. By the way you use the EBI mapping interface to generate rules is identical, regardless of source and target document syntaxes. Notice that this example shows mapping from a database schema to an XML schema. We'll be showing other document syntax combinations through the rest of this demonstration, but in every case, the way you generate rules and specify actions is consistent.
Thanks, Dave. You can see from the example Dave just showed how mapping with EBI takes better account of the complexity, scalability, and maintainability requirements of real-world mapping projects. But even with an elegant mapping interface like the one EBI offers, mapping large documents remains time-consuming and can be a source of errors that extends testing time and increases deadline pressure. That's where smart mapping comes in. Smart mapping is a breakthrough in automated mapping technology that can reduce the time needed to create complete, large-scale data transformation maps by 70% or more compared to using conventional drag-and-drop methods. Unlike other automated mapping approaches, smart mapping requires no setup, provides automated mapping assistance in any situation, even when mapping unfamiliar document types, and is highly configurable to suit individual circumstances and preferences. The Smart Mapping Engine is integrated with the EBI Transformation Rule Set interface that Dave just demonstrated, which allows it to be used in multiple ways and in multiple parts of the mapping process. So let's take a look at the simplest way to use Smart Mapping by enabling pop-up hints. Dave?
As Jim explained, the simplest use of Smart Mapping is at the element level, using pop-up hints. In this example, we're looking for the best match for the database column under the cursor in our XML target document on the right.
Okay, thanks, Dave. So you can see how Smart Mapping can help you to identify source-target associations at the individual element level. But for real mapping efficiency, we need to be able to automate mapping of large document subsets, even entire documents, at once. So that's what Dave will be showing next, mapping at the document structure level. Dave?
As Jim mentioned, I'm going to use Smart Mapping at the document structure level to generate multiple map rules at the same time. Note that this time, we're mapping an EDI document to a flat file document. But remember, Smart Mapping works with any combination of XML, EDI, database, flat file, and spreadsheet document types. We'll explain the different methods Smart Mapping uses in a minute. Once the Smart Map Structure option is selected, an approval editor is displayed, allowing you to approve, modify Smart Map suggestions. In addition to providing Smart Mapping suggestions, the approval editor also displays the structure of the proposed rules to be built based on the structure of the source tree.
Thanks, Dave. I mentioned earlier that one of the main advantages of EBI Smart Mapping is its configurability to suit different mapping circumstances and preferences. Virtually all other automated mappers use dictionaries containing synonyms to facilitate the discovery of source-to-target mapping associations. Dictionary-driven mapping is an improvement over manual mapping when associations between source and target elements are known and documented, but it isn't the most productive method in all circumstances and doesn't provide a solution at all for some common mapping situations, as we'll see. Smart Mapping avoids the limitations inherent in other automated mappers by applying 4 different automated methods for source-target matching and transformation rule generation. The first is the dictionary method, which uses synonym dictionaries to automate discovery of source and target matches. The second, the matching ID method, uses element tagging in document schemas to identify source-target matches. The third is the property method, which employs pattern matching heuristics to discover source-target matches based on structure, naming, description, and type similarities. And finally, there's the history method, which applies statistical correlations from past mapping efforts to infer source-target matches and to generate transformation rules. Now let's look at each smart mapping method in more detail, starting with the synonym and matching ID methods. The synonym method is useful when you have a pre-existing set of source-to-target element associations that can be used to guide mapping. You can create a dictionary of associations using the EBI Smart Mapping interface, or import them from external files or spreadsheets. Once your dictionary is built, Smart Mapping can use it to match source and target elements. The matching ID method also automates mapping based on known associations, but instead of using synonyms to identify source-to-target matches, it uses tags on document schema elements. Among other advantages, the matching ID method is immune to changes in element names because the tags are independent of other element attributes. Now let me hand it back to Dave to show how these methods work. Dave?
In this example, I'll simply create a new dictionary by importing external definitions from a comma-delimited file. Now I'll save my dictionary and we'll move on to the dictionary preferences. As you can see in the Smart Mapping Preferences screen, under the Synonym tab, you not only can define a default dictionary, but you also have the ability to enable or disable additional properties. Now, in our rule set, you'll notice that our Smart Mapping suggestion has matched address in the source schema to ADDR in the target. Next, I'll explain how to use the Matching ID method. The Matching ID method allows IDs to be defined to each node in a schema. These tags can then be matched to corresponding IDs in another schema. Jim will now explain some of the downfalls of these methods. Jim?
Okay, thanks, Dave. So the synonym and matching ID methods are useful ways to speed up the mapping process, especially if you already have associations that can be imported to create a dictionary. But these methods also have limitations. First, they require that source target associations are known, so you need to define them before you can automate mapping. Second, the associations need to be maintained, as new associations, spelling variations, and other changes occur over time. So there's a maintenance requirement, especially for the synonym method. Finally, the synonym and matching ID methods don't work if you're transforming unknown document types where no predefined source target associations exist. This last limitation is a critically important one to note. Virtually all other automated mapping tools stop here because they require a mapping dictionary. But mapping unfamiliar document types is a frequent requirement in integration projects. So if the synonym and matching ID methods can't help there, what other options exist? When predefined source-to-target associations don't exist, Smart Mapping offers an automated method that can still save you large amounts of time, the property method. The property method analyzes your source and target documents looking for structure, name, description, and type similarities. You can configure its pattern matching behavior so that matching can occur across different attributes, like matching names with descriptions, and even match acronyms, camel case, and different word ordering in any combination. The only way to really understand the power of the property method is to see it in action, so let's get back to our demonstration and take a look. Dave?
Some of the configuration options for the property method are ignoring the case, underscores, or spaces. You can also analyze a string to see if it starts with, ends with, or contains the property being suggested. Check Segment ID will generate the appropriate segment and element position as search criteria, for example, BEG03. You can also reduce the confidence level of the property method if there is a data type or data length mismatch, or suggestions that would truncate the data. The property method settings allows you to configure parsing options. The Smart Parser is a process by which a string is broken down into a group of pieces, called tokens, and then the group is compared to other groups of tokens. If enough of the tokens in one group match the tokens in another group, then that particular candidate node will qualify as a match. For example, if we compare two nodes called Global Trade Item Number and Trade Item Number respectively, none of the previously discussed options could conclude a match between these two. However, if we break each name down into word tokens, we can now compare the two groups of word tokens and see 2 out of 3 of the Trade Item Number tokens exist in Global Trade Item Number. This is the basic premise for how the Smart Parser works. The option to break strings into tokens is similar to the Smart Parser, but allows you to define how the word tokens are broken, such as camel case, underscore, space, or custom delimiter. You can further ignore the token order, check for acronyms, and even ignore the acronym order. Enabling some of these options might produce undesired results.
Great, thanks, Dave. As we've just seen, the property method picks up where the synonym and matching ID methods stop, giving you the ability to automate the discovery of source and target matches even when you have no experience with the documents you're mapping. But like the synonym and matching ID methods, the property method does have some limitations. First, it doesn't take structural context into account. For example, we might want to match contact to bill to name if it's in the billing information section of our source document, but if it's in the shipping information section, we might want to match it to ship to name. And second, while the automated methods we've seen so far identify source to target matches, they don't determine which rules to apply to derive target values from source values. They always generate a default move rule. So these methods are very useful in their intended circumstances, but they still help with only part of the mapping effort. But there's one more smart mapping method that addresses these limitations and produces not only the most accurate mapping suggestions, but also delivers the highest level of time savings, and that's the history method. The history method automates mapping by applying associations and transformation rules based on similar mapping situations that have occurred in the past. Setting it up is easy. You use the Smart Mapping History Profile feature to generate mapping history profiles for one or more of your existing maps. When you use the history method, you simply choose a mapping history profile, and Smart Mapping takes over from there. The history method is generally the most accurate and useful smart mapping method because it's based on actual mapping experiences. You can even use a history profile generated for one document type or version and use it to automate mapping for different document types and versions. For example, you can use a mapping history profile for an X12 EDI 810 invoice to automate mapping for an X12 EDI 811 service invoice because these documents have similar structures and contents. If your mapping history includes multiple different associations and transformation rules for the same source to target matches, the history method will suggest the one that is the most commonly used based on recorded mapping statistics. And unlike the other smart mapping methods, the history method carries the specific transformation rules that were applied in the past and applies them to new cases. That further reduces the effort needed to produce a complete map. Okay, now let's turn back to our demonstration and see how the smart mapping history method works. Dave?
As Jim previously mentioned, we'll need to first create a history profile. Simply check the maps you want included in the history profile and save. Similar to the synonym method, you can define additional preferences and a default history profile. Using the history method for smart mapping, we'll use the rules referenced in the history profile, such as the concatenate rule that we see here. Now back to you, Jim.
Thanks, Dave. Using the history method that Dave just showed us, with the right mapping history profiles, you can generate 80% or more of your map while automatically applying best practices, even when the person doing the mapping lacks experience with similar maps or document types. No other automated mapping technology provides that level of mapping productivity or contributes so much to higher map quality and shorter learning curves. Each of the 4 automated mapping methods supported by the Smart Mapping system has advantages in different circumstances. The synonym and matching ID methods excel when specific source-to-target associations are known or preferred. The property method is the only method that works when no predefined associations or mapping history exist for a new document type. And the history method provides highly accurate mapping guidance when mapping history exists for the same or similar source and target types. But these circumstances aren't disjoint. For example, you might have mapping history that covers most, but not all, of the source target element associations needed in a new map. Using the history method and the property method together would give you full coverage in such cases. That example illustrates one of the most useful and powerful aspects of smart mapping, its ability to combine multiple automated mapping methods seamlessly and simultaneously to produce the results that you need in each mapping situation. Okay, Dave, let's see how that works.
The Smart Mapping preferences allow you to enable methods used by Smart Mapping, as well as the weight to apply to each method suggestion. The weight option allows you to determine the importance you would like to place on suggestions for each method. Because Smart Mapping always has at least one automated mapping method to use, and even suggests the best one to use in each case, your mapping effort changes from making many small decisions for small details to choosing from among a few high probability options and customizing the result for your particular case. Especially when using the history method, you can even smart map an entire document at once, which can produce 80 to 90% of the rules for your new map.
All right, thanks, Dave. Smart mapping is part of a broader EXTOL strategy to reduce the time, effort, and cost of design time integration tasks. This chart shows the overall result of applying all of the design time automation features in EXTOL Business Integrator, which in addition to smart mapping include automated metadata capture, automated partner endpoint generation, automated change data capture, and automated document change migration. EXTOL is the only integration technology vendor who's figured out how to harness all of these design time automation features to reduce your overall integration development effort, cost, and delivery time by 60% or more, producing an investment return that's unmatched by any other business integration offering. Well, that wraps up our demonstration of EXTOL Business Integrator Smart Mapping, so let me quickly recap the main points we've covered today. We've seen how you can use smart mapping to speed up the mapping process and reduce mapping errors by exploiting automation. We've shown how smart mapping provides automated mapping assistance in every mapping situation without requiring setup effort. And as you start accumulating mapping examples, smart mapping becomes more effective over time, generating a higher percentage of the mapping rules that you need for new situations. We also saw how you can take advantage of multiple automated mapping methods simultaneously with configurable method options, matching behavior, and method weighting, so you can tailor your smart mapping environment to suit your preference. Finally, smart mapping is the only automated mapping technology that is designed to support sharing of mapping history between companies, because unlike simple map sharing, smart mapping history profiles enable sharing of mapping history and best practices without exposing you to security or intellectual property violations. In the next phase of our smart mapping strategy, EXTOL will deliver a cloud-based mapping history repository that fully exploits this aspect of smart mapping technology. We'll have more to say about that soon, so please stay tuned. To find out how EXTOL can help you to save time and reduce cost with your next integration project, contact us by phone or email to schedule a live demonstration or in-depth discussion of your integration project requirements. Or visit our website for detailed product information and additional on-demand demonstrations. Thanks for joining us today. We look forward to hearing from you soon.